But when you add it with the signal, AC signal, what does it do to the AC signal? When you add a DC component to the AC signal, no, what it does, you see this. First of all, let's assume a signal without DC offset. Without DC offset, your signal will start from 0 volts. It will go up and then it will come down to 0 and then go to the minimum and then come back to 0.
Yes.
Without DC offset. If you add DC offset voltage, okay, then your signal will start from the value of the DC offset.
Yes.
Okay. So your DC offset, it will shift your signal up by the value of the DC offset. Okay, so now let's look here. So here we have 1 volt, 2 volt, 3 volt, 4. So how much DC offset you see here?
4.
Solid. How much DC offset here? Listen. 4. Because your signal starts from 4. So that means from 0, it has been shifted to 4. So your DC offset is 4. The DC voltage in the signal. If there is no DC offset, then the signal will start from 0. That means there is no DC offset. Sir? Everyone understand?
Yes.
Now, the DC offset could be negative. It is possible. So if the DC offset is, for example, minus 1 volts, then your signal will start from minus 1. Easy, right?
Yeah.
Very good. I like that. Huh?
The kg.
kg, yeah. Okay, so you understand DC offset? So DC offset will shift your signal up or down by the value of DC offset. If DC offset positive, up. DC offset negative, down. Okay, now. So now you see the peak, one peak voltage and the other peak voltage. There are 2 peaks. Okay, one on this. One is here and the other one is here. This peak and this peak. And you want to find how much voltage you have in between these 2 peaks. Okay. And the way you can do it is, there is very easy formula here, which is the maximum voltage. What is the maximum voltage here? On the top, 7. Minus, what is the minimum voltage here? 1. So 7 minus 1, 6. So 6 volt is peak to peak voltage. Okay, and if you can actually count it. You see, starting from 1 volt, so 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, because it starts from 1 volt, so 2, 3, 4, 5, 6, 7, 6 volts. So 6 volts is peak to peak voltage. So whenever I say peak to peak voltage, that means it is the voltage from one peak to the another peak. Okay, maximum peak to the minimum peak. Now there is another thing, which is peak voltage, which is the voltage just going on the one side, which is this one. And the easy way to find the peak voltage is peak to peak voltage divide 2. Divide 2. So peak voltage is 3, and you can see it from here. So it starts from 4, so it's 5, 6, 7, 3 volts. Okay. So peak to peak voltage is 6 volts in this case, and peak voltage is 3 volts. So now peak to peak voltage, we represented it with VPP. VPP. So whenever you see the word VPP, that means peak to peak voltage, and whenever you see the word VP, it means peak voltage.
What's the second one?
VPP and VP. 1P. 2P, peak to peak, 1P. P. This is just a symbol. What is this? Yeah, this is just an example, and this is for this figure. This for this figure. This is just an example. VPP, peak to peak voltage, and VP, peak voltage. So you know these words: frequency, period, DC offset and peak-to-peak voltages.
This graph, the VP voltage, the VP is 7. What is
VP 3.
3. From the DC to the peak.
Everyone understands? So now, so you know this signal, right? And regardless of the shape of the signal, whether it is a sine signal, whether it is a triangular signal, or whether it is a square signal, you will have these fundamental quantities in there. You will have a frequency, you will have a period, you will have a peak-to-peak voltage, you will have a DC offset. Okay? Regardless of the shape of the signal. Okay? Now, so what I will do, so we want to use this to generate a signal, right? Okay, for example, sine signal, which is this one here, or this shown here. Okay. So this is sine. I'll keep it like this. If you want to have a square, you will press this, and triangular, you will press this. So just for today, we'll keep it like this. And what are the things which you need to provide here? Frequency. So you press this, or okay, let's press this frequency. You see this frequency here? It is highlighted. Okay, and now you will enter a value. So for example, we want 100 hertz. So you see this menu, 1, 0, 0, and hertz. You see this hertz?
Okay.
And here it is. So this is 100 hertz. So you type the value here and select the hertz, megahertz, kilohertz, and it will take that value. Okay. So now 100 hertz has been set. Second thing we want to set is the peak-to-peak voltage. For that, you will see this amplitude. You will press this, and now it is on the amplitude. Okay, and how much you want? 1 volt. So it is already 1 volt, but I'll say 1, and here you press VPP, and this is 1 volt VPP. Okay, and what is the next thing we have? DC offset. Okay, so I want to keep a DC offset also. So for the DC offset, you see this offset? Okay, I'll press this, and now it is the DC offset here. And I will type a value, for example, 0.5 volts. So it will take 0.5 volts is, by the way, 500 millivolts. Same, huh? So that's why you see 500 millivolts. Now your signal is being produced. By the way, this is not a signal. This is just a figure. So the question is, where is my signal?
Just on the side.
Huh?
You press on the side.
No.
You add.
It is already signed. It is generating the signal. It is generating the signal here. Now we cannot see it. In this it is generating. To see the signal, we use another equipment, which is this beautiful machine, which is called oscilloscope. 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 So whenever I say oscilloscope, this is a machine which you use to see and measure the signal. Sometimes it also gives you some measurements. Okay? So the question is how we connect this with this. This is the output of this, which is on. Make sure this is on. If it is off, the signal, the output will be off. So you need to turn it on. Okay? And to connect this one with this, we'll use B and C cable. B and C cable. And this connector. Now you know why we use this connector. This connector will go here. Make sure it is solid. Okay, and this will go number 1. Okay. I'll connect it with number 1, and I'll start it. And I connect this one here. Okay. You can also connect it with the number 2, but for sake of convenience, we always use number 1. Now give it some time to come up. Okay. Right now it looks garbage. So you see this auto range, press the auto range. Okay. And still, now you have this signal. There is one more thing which we need to careful. You press on number 1, and you see right now it is 10x probe. You just need to make sure a few things. Huh? Press on number 1, and you see this one is 10x. It should be 1x. So press number 1, and you come here, you press this. So this is 10x attenuation. We want it 20, 50, 100, 500, 1000, 1x. That is what we want. Okay. So press number 1, and attenuation should be 1x. Otherwise, it is attenuation. If it is 2x, your signal will be double. 100x, your signal will be 10x, 10 times. We just want to see as it is. We don't want any x multiplication. Okay. So keep it as 1x and then auto range again, and you will see the value here. You see the signal here. Okay. And here you see the yeah, let's talk about that. Yeah. Where is that table? Can you flip it? Bring this one in front of you. There are only 2 things which you need to understand about this figure. First of all, you see this green, which is shown here, this green notch. This green, not green, yellow, which is this one, this arrow, small arrow here, on the side, the small arrow. This is 0 volt. 0 volt. 0 volt. This one represents, yeah, the arrow. The arrow, yeah, this one, this arrow. It represents, and then it actually shows you very clearly here. Maybe it is not very clear here, but it is very, so this one, so this line is 0 volts. It represents that this whole line is from here to here is 0 volts. Write down. This represents that the 0 volts. Okay. Okay. Now, you see this arrow on the top here. This one, 0 time. It does not mean that the time before it is negative, but this is just for the sake of reference. This one is the 0 time. Time. 0 time. Now you see there are these squares. Yeah? These squares. Okay. These squares are used for measurement. Okay. Just by looking at these squares and counting these squares, you can tell how much voltage is there and how much time is there. Okay. Now, let's look here. You see in this 500 millivolts in this column, this is how much each block represent on the voltage axis. Okay, voltage is this axis, right? This is our time axis and this is our voltage axis. So 500 millivolt, each block represents 500 millivolt. Write down. Each block represents 500 millivolt, and this is the value you will see it here. Millivolt is each block on the voltage axis. So if you want to see how much voltage you have, all you need to do is count the blocks on the voltage. Huh? So 1 block, 2 blocks. So we have 2 blocks. So 500 volts plus multiply 2. So we have 1 volt. Okay.
Again, Doctor, can you repeat for the blocks?
Each block represents 500 millivolt. Right? So if you want to see the voltage, this is one block, 2 blocks. So this whole represents 1 volt. So is it the 1 volt, is it our VPP?
Yes.
From here to here?
Yeah,
That is our VPP. Sir? So it shows you the VPP. So you count the blocks, how many, so if you want to measure the, up to any specific point you want to measure the voltage, you just count the blocks. And this is not very precise, but it will give you some idea. Okay? So this is 1 volt peak to peak, quickly you can see. Now, you see this value 5 millisecond on this. It's not very clear, but it is 5 millisecond, this value. This represents how much each block on the time axis. So write down, this is on the time axis for each block. 5 millisecond.
There was capital M before.
Don't worry about that. I mean, I don't know. I never.
Doctor, every time we measure graph, the same, each block is the same.
No. Depend on the VPP, depend on the frequency, it will have a different value.
The block is 500 millivolts. Is it always the same with the DC also?
No, not DC also, VPP.
VPP.
No, not DC also. No, it has nothing to do with DC also. Yeah. But using this block, you can find the DC offset. Because you see, your signal from 0, it has been moved 1 block up. So that means the DC offset is 500. Yes. Everyone? Yes. Now, so each block on the time axis represents 5, how much is it? 5 millisecond. So if you want to find the period, how many blocks we have on the period side? So we start from 1, 2. So that comes to 10 millisecond. Is this the period of 100 Hz frequency?
No.
1 over 100. 10 milliseconds, yes. Yeah? Frequency is right. So just by using this, you can quickly analyze your signal. Okay. And I want you to understand, because you might see this figure in the exam. So they will give you this, and they'll ask you how much each square represents on the voltage and on the time. So you have to look at this, and then you need to figure out, the values, the right values. Okay. Now, everyone is okay so far? Sometimes, if this is too much information in one day, so students go crazy, but alhamdulillah, so far I don't see any craziness. So far you are talking, you're making sense. I don't know what will happen after the class. I don't want to know. But hold your emotions in the class, yes?
I didn't understand the last one, frequency. How can we do it? How can we do 100
The time is time period. So how we find the time? This is 1 block, 2 blocks. So 2 block for 1 full cycle.
Yes.
And 1 block is 5 millisecond. 1 block. So 2 block represent 10 milliseconds. So this is the period. So 10 millisecond, if you take the 1 upon, you will get 100 Hz. 1 over frequency, or 1 over period is frequency, or 1 over frequency is period. 10 milliseconds. Make sense?
How can we know the offset?
Just looking at the blocks.
No, the offset, yeah.
Okay. So how much is it up? 1 block,
Yeah.
which represents 500 millivolts, which is 0.5 volts. Okay. One last thing. I know there is a lot of excitement and you want to jump on the equipment and use it, right? You know? You should. You want? Yeah, just give me a few more minutes and then I'll let you loose on the equipment. Okay? Now, these are the visual inspections. These are the visual inspections. You can quickly look at the blocks, count the blocks on the voltage axis and on the time axis and get some sense of the values. But there is, you see this measure button? You click this measure button and you will see this value and channel 1. And here you select the type. So for example, frequency. So here it is. It shows you frequency, 100.4 hertz. So now it is measuring the frequency for you. And the measured value is sometimes 90, it is fluctuating, but 99.9, 100.2, something like this. Okay. And so this is, here it is, channel 1 here. So this is the value. And if you want to measure the period, this way, here it is. This is 10 millisecond. Right? 10 millisecond is the period. And if you want to measure some other thing, you keep pressing. Mean is the average, which is about 5 millivolt. By the way, mean, what is mean? Average. But if you have a pure signal, AC signal, the mean should be 0. Because plus, minus should be 0. So the mean will be, what did you say? DC offset. Okay. So then using this equipment measure, and then you can select the value which you want to measure, and you can measure different parameters. Now, you see this one? This is, what do we call it? Voltmeter or multimeter. So whatever word I use or you see it in the exam, this should come to your mind. And you see these black ticks, the divisions, right? Now, forget about the numbers. Don't worry about the numbers. Okay? Just look at these ticks here. And I'll count it for you. This is 5, 10, 20, 30, 40, 50. So there are 50 ticks, these black ticks. From here to here. Don't worry about the numbers. There are 50 ticks all the way. Okay, small ones. Okay? These black ones. There are 50 of these. Okay? I'll count it for you. We're spending so much time, huh? So don't worry about the numbers. Okay, I'll talk about this, okay? You all can see that? This is 50 ticks, black ticks. Divisions. Huh? Now, you see this black manual here? This is what we select to measure the DC voltage. Okay? Measure the DC voltage. Now, if these values here, 0.1, 2.5, 100, 50, 250, and 1000, these represents the maximum value which you want to measure. So minimum is always 0. Maximum is you select from here. So for example, I set it to 10. Okay, so that means this whole scale is maximum value is 10. So 0 to 10. Okay, so now you have 50 divisions and the full scale is 10. So each division represents how much voltage? 10 divide 50. You have 10 volts, you want to divide it into 50 divisions. So 10 divide 50, 0.2 volts. Okay, so that means if you measure, this needle will move. So what you will do, you will count the number of divisions. Okay, and to get the value, number of divisions multiply 0.2. And that will give you the value. Okay, so I'll keep it here at 10. Let's generate some voltage, and I'll just quickly show you. Do you understand this, right? And do you want to see it, or you are comfortable with that without seeing it? I don't know how, who tangled up these. I hear things like this. My things are, everything is straight. Anyway. You see see for the black is always black. Okay? And for the voltage, you will put it here. Right. Okay, always here. Okay? And the red will go to red. And I have 3.93 volts. Okay? So I'll put the output, and you see the needle has moved. Hassan, can you count the number of ticks? So it is right now 10. Okay, how many ticks we have? So it is 10, 15, 16, 17, 18, almost 18. So we have 18 ticks. Okay? So 18 times 0.2. I don't know, anyone has a calculator quickly? Three point six is 3.93. Okay? Which is fine, because this is not very precise. So that's how you will get it. So if you want to measure the voltage, you will put these anywhere you want to measure, and you will count the ticks, and depending upon if you have 10, then it will be 10 divided 50. If you have 50, it will be 50 divided 50. Okay? But this, you can only measure voltage between 0.2 steps. So first value, the minimum value you can measure is 0.2. Then after that, next value, 0.4. If it is 0.3, no, you will not know. So it will, either you can measure 0.2 or 0.4. Then, and then move on and on and on. And if you want to really measure a precise value, you can select the scale to, for example, 2.5. So it will be 2.5 volts divided 50. So you can, your steps will be smaller. Okay? So you can increase the resolution. Okay? Now what I want you to do is, Blackboard, there is a document, lab equipment, new equipment. That is for you, for this lab, because this is the new equipment. Open that document, and there are certain procedures which you need to do. We are using this equipment. It will give you a good familiarization with the equipment. Okay, so go back to your stations, and good luck with the procedure.